Okay, guys, here's the commentary on this problem. This is optimization, and here they're always going to ask you, what is the maximum volume or the maximum size of something, or the maximum, or they could say a minimum value for something given a scenario. Okay, usually you'll have to define an equation, define side lengths, or define various dimensions, and you're probably going to have more than one variable. They will usually give you sufficient information to be able to rewrite the value of one of your unknowns in terms of the other unknown, so that you can take a derivative and maximize or minimize the problem. In this case, I've assumed that the container is closed, and when they say here 48 square meters of metal, I'm saying, well, that must be my total surface area of my container. Now that is really important to be able to find the value of the height in terms of x. And they've given you a bit of a clue there, because they've told you show the height is this, and it's all in terms of x. All right. I've then found my total surface area. I've equated it to the given value, and over here where I had 24 minus 2x squared over 3x, I actually split it into two separate fractions, and then I could further simplify it to get the value that they had found. All right, now they have asked us to determine the dimensions of the container with a maximum volume. So they're wanting us to maximize volume. That means I need to find an equation for volume, and I know that volume is length times width times height, and I can find the equation of my volume with respect to my side length x. Now if I take the derivative of volume with respect to x, I can find the value for x, which will give me a maximum volume. Take the derivative and put it equal to 0. Remember, a maximum or a minimum occurs where my derivative is equal to 0, because that's where my turning points are. And I find my values, and I get x equal to positive or negative 2. Now we know the length of a side cannot be negative 2, so I discard the negative, and therefore my value for x must be 2. Before I can say that the value of x is definitely a maximum, I need to confirm that it's a maximum using my second derivative test. And I take my second derivative and I substitute in the value of 2, and I get a negative second derivative. Remember, if my second derivative is negative, that means that it is a maximum, because the shape of my graph there is concave down. So therefore I can say there's a maximum value when x equals 2. They then asked for the dimensions of the cube when there's going to be a maximum volume. So I found my length is 4, my width is 2, and my height will be 4 minus 4/3 meters. Okay. They then asked what that maximum volume will be. So I substitute the value of 2 into my volume formula, and I get 64 over 3 cubic meters. Now remember, if you don't have a calculator, you would leave it at 64 over 3 cubic meters. But if you had your calculator, it's approximately 21.3 cubic meters. Enjoy your day.